All right, let's dive into an algorithm that's an absolute game changer for keeping systems stable. We're talking about the token bucket.
Okay, so picture this. You've just launched your new API. It's awesome. And then, boom, it gets featured on a major tech blog. Suddenly, you're looking at a tidal wave of requests about to slam into your servers.
So the big question is, how do you stay online and fast for everyone without your servers just, melting down? Well, the answer is this really elegant, surprisingly simple rate limiting algorithm that pretty much every major system relies on.
All right, let's get into it. The token bucket. To really wrap our heads around how this thing works, we're going to start with a super intuitive analogy. Think of it like this.
So, what is a token bucket? At its heart, it's all about finding the perfect balance. It lets you control the average rate of traffic over time, but, and this is the key part, it also gives you the flexibility to handle those short, temporary bursts.
Okay, so let's follow a request on its journey. First, imagine you have a bucket. This bucket is getting filled up with tokens at a nice, steady, constant rate. Now, when a new request comes in, it has to grab one token to get through. If there's a token, great, the request passes. But if the bucket is empty, sorry, the request gets rejected or maybe has to wait. It's that simple. And the size of the bucket, that's your burst capacity. How many requests can flood in all at once?
And this is what makes it so powerful for system operators. It's not just a clever idea, it's a mathematical guarantee. You can literally calculate, with a simple formula, the absolute maximum number of requests your system will have to handle over any stretch of time. That predictability, it's everything when you're trying to keep things stable.
Okay, the analogy is great, but let's get real. How does this actually work in code? Let's talk implementation, complexity, and some of the classic pitfalls you've got to watch out for.
You might think this requires some complex setup, but it's shockingly simple. To build a token bucket, you literally only need to keep track of 4 little pieces of state: the max capacity, the refill rate, how many tokens are in there right now, and the last time you refilled it. That's it. No crazy data structures, nothing that gets bigger over time.
Okay, so here's the secret sauce. You might be thinking, is there some background process just constantly dripping tokens into this bucket? Nope. The really clever trick is what we call a lazy refill. The system doesn't do anything until a new request shows up. Then, and only then, it does a quick calculation. Okay, how much time has passed since the last check? Let's add that many tokens. It's incredibly efficient.
And that lazy approach is what gives the token bucket its killer feature, its performance. We're talking O of 1, or constant time complexity. So what does O of 1 actually mean? It means that every single check is ridiculously fast. It doesn't matter if you got 1 request yesterday or 10,000 in the last second, the calculation to see if a request can pass takes the exact same minuscule amount of time. This is huge. It means your rate limiter itself will never ever be the bottleneck. You get protection without sacrificing speed.
Now, it sounds easy, and it mostly is, but there are a few classic tripwires. For instance, you absolutely have to use what's called a monotonic clock. That's just a fancy way of saying a clock that only ever moves forward, so someone messing with their system time can't break your logic. Concurrency is another big one. You've got to make sure 2 requests don't try to grab the same token at the exact same time. And don't forget to make sure the bucket doesn't overfill.
All right, so we're pretty solid on the token bucket now, but it's not the only game in town. So how does it stack up against the other options? Let's do a little comparison.
First up, the big one. The question I always hear, isn't this just the same thing as a leaky bucket? It's a super common point of confusion. But nope, they sound alike, but they behave in completely different ways.
Here's the best way to think about it. The token bucket is all about flexibility. It allows bursts. It's like a bouncer at a club who has a bunch of entry passes. If a group of 10 shows up and he has 10 passes, he lets them all in at once. The leaky bucket, on the other hand, is about uniformity. It's like a single turnstile. No matter how many people are waiting, they can only go through one by one at a steady pace. It smooths everything out.
And this chart really drives the point home. You've got other algorithms, sure. The fixed window is simple, but it has this nasty bug at the window's edge that can let in double the traffic. The sliding window log is super accurate, but it costs you more in performance. When you look at the whole picture, if what you need is that perfect combo of O1 speed and the ability to handle bursts gracefully, the token bucket really is the king. So to wrap it all up, what are the big takeaways? First, the token bucket gives you that perfect mix. It enforces a long-term average rate, but it still lets you handle short-term traffic spikes. Second, it is insanely efficient. O1 time and space means it's fast and light. This is why it's the absolute go-to choice for things like API gateways and setting up per-user quotas.
But that leaves us with one final and much bigger question. A single bucket on a single server is fast, it's efficient, it's beautiful. But what happens when you're running a massive, global distributed system? How do you make that work across hundreds of servers all over the world? Now that's where things get really interesting.